Hello, and welcome to this demo of the Pure Service Orchestrator, how to install it via Helm. So real quick, I'm just going to show you we have a fairly clean Kubernetes cluster, nothing running, just a couple of nodes here. You can see that we have no apps installed via Helm. We'll search my repos. I've already added the repo that contains this plugin. We can see here, okay. The Pure repo we'll install from, so now we'll do take a look at previously when you were using, if you used the Pure plugin before, you actually used the JSON file. What we're going to do now is I already converted it, but if you want to, there's some links where you can convert that to a YAML, which is what Helm requires to read. So same information, just in a slightly different format. Helm install, Pure Service Orchestrator. I can actually spell this. I'm going to point it to my file here that has the arrays. So that quickly downloads, installs. Very small microservice. So now we can see Pure Service Orchestrator is installed. We don't have any persistent volume claims yet. I'm going to install a small database system, pretty cool one. And without providing any other parameters, we'll see what happens here. It'll take a few seconds. All right, we can see that the containers and the pods that make up this cluster are starting up right now. That installation installs a few things. So we have some Kubernetes pods, one for the 3-node system that we deployed. That's the default for that chart. You can actually change that if you'd like. It creates a stateful set that has 3 pods in it, so it'll make sure there's always 3 running. Each one of those will have its own persistent volume claim. And we'll bring over the GUI for that database. Basically, I was just forwarding the interface. You can see we have CockroachDB up and running. Everything is working there. We can see that there was the persistent volume claims, and each one of those will map to somewhere on the storage array. Now I have multiple flash arrays, so we'll check this first one. See if we can see the names here. So if I can just search on F8F, I should be able to filter out all the rest of my volumes. It's not on this array. Let's look at my M70. And now you can see all 3 were created there. So what do we just see there as the volumes were created on the M70 and not the M50? So as we create that request for a persistent volume, is that it goes to our API in the Pure Service Orchestrator. The Pure Service Orchestrator is able to collect and weigh metrics and filter out the arrays to meet the demand or to meet the requirements of that application. So at that point, it the fleet provisioner determined that the M70 has plenty of performance and plenty of capacity and was the best fit for those volumes. So it decided, just based on the current load and the current free capacity and a few other metrics, where to place those volumes. So now we are looking kind of at a different way of provisioning that, and a way that kind of fits the cloud model that your developers and any developer or a site reliability engineer would expect. And basically being able to group our resources either by rack or by zone, and being able to kind of provide that availability, whether it's across a row or a rack or between clouds. So today, we can easily provide a way to mark in Kubernetes the failure domain or the rack, basically just a key value store of where those compute and the controller nodes are living, but then able to apply that as well via the Pure Service Orchestrator to the flash arrays or flash blades. So now we're able to kind of logically group our arrays with the compute nodes, and when you will see here in a second during the demo is that now you're able to actually take that and apply that logic to your application and have it be within a zone, as you'll see here in the demo. All right, so really quickly, we're just going to look at, this is the new YAML file for your labels, basically what we were talking about earlier, being able to provide those labels and zones for your environment. And we'll quickly just upgrade via Helm our Pure Service Orchestrator. So Helm upgrade, the name of the release, which is Pure Service Orchestrator, and chart. So we'll go to the Pure repository. It helps if you type it in correctly. And point it to our new labels-based YAML file. Applies really quick. We can double check our installation here. So we'll do a describe, look at the config map, type in Pure Provisioner there, and you can see, like, in that mess down at the bottom, basically now we have our zones applied. So we have arrays matching to our zones that are applied already to our compute environment, and we're going to install a new application. So the same database, but now we're going to actually install this based on some changes that I made. So we'll look at this real quick in a second, but basically I changed the Helm chart to actually utilize the zone. So we're saying zone B, which will be the M50. So as this applies, what it's doing now is going, okay, no matter what the capacity is on the two arrays that we have in the environment, it has to be on zone B. So if there is no capacity or no way to service that request, it obviously won't provision. But see, all the pods started on worker 8, which was in zone B. Obviously, in the real world, you'd want to have more than one worker in each zone, but this is just for a quick show off. And we can see that my data directories were created on the M70. If we look at that directory, nope, it's not there. Now back over to the M50. We search on that name. Filter just not part of it. Yep, and it's attached to worker 08. You may say, hey, how do I make that changes? How do I do that? So I'm just going to show you real quick inside here. There's just a few lines that you add to that. So for the node affinity, basically saying, hey, compute needs to be on zone B right there. And now you can see the volume claim as well for zone B. So matching our environment here, so we can see that we have our zones all created, and now developers or DevOps teams can actually just apply a zone and make sure that it gets all the services it needs, either compute or storage, via the Pure Service Orchestrator. I want to let you know some of the other automation and integration tools we have for your cloud, depending on whether it's VMware or Microsoft or OpenStack, containers or hybrid cloud, with public cloud type environments. So you can quickly check any of those out with us at Pure Storage. Remember, you can download the Pure Service Orchestrator today. Go ahead and check that out. There's a couple places you can do that. Also check out our open source portal, code.purestorage.com, where you can get lots of information about how we've integrated with DevOps tools, scripts that have been written by customers and other Pure employees. So check that out. So thank you again. I hope you appreciate this demo and that it can help you achieve storage as a service for your Kubernetes or Docker environments. Thank you very much.